Hi everyone, thanks for joining us at our virtual community science workshop. My name is Mr. G and today we're going to be building a Thaumatrope. Keep in mind, Ms. Shaver is the one building the project in this video. If a light is flashing on and off for more than 30 times a second, we see it as a steady light. We don't notice the flickering. When movies play at movie theaters, the screen is actually dark about half the time. But because the bright picture is flickering 72 times a second, we don't notice the moments of darkness between the pictures and our brains perceive normal movement. This is called the persistence of vision and is the basis for how the Thaumatrope works. The materials we're using to build our Thaumatrope are a dowel, a cardboard circle, glue dots, and a cardstock printout that has two blank circles, an image of a bird and an image of a cage. We'll start the build by cutting out the 4 circles on the cardstock printout. Para mejor resultado, corte sobre las líneas gruesas. Be sure to cut on the thick, black line for the best results. Draw your own design on one side of the 2 blank cardstock circles using pencil first, then trace over it with a dark pen or a marker. Dibuje su propio diseño en los círculos de cartulina en blanco usando las lápiz. Next, slowly and carefully push the dowel along the corrugated lines that are parallel to the center of the circle. The dowel should be pushed inside about 1 to 1.5 inches. La clavija debe penetrar de 1 a 1 pulgada y media entre el cartón. Place 1 punto de goma on the center of the circle and attach the cardstock circles by gently pressing them onto the glue dots. Be sure that both images are facing right side up when you hold the dowel in your hand. You could change the images by gently pulling the cardstock off the cardboard circle and gently pressing the new cardstock onto the glue dot. Puede cambiar el diseño levantando con cuidado la cartulina sobre el círculo de cartón y suavemente poniendo la otra imagen sobre el punto de goma. Para ver tu Thaumatrope en acción, spin the Thaumatrope by holding the dowel between your fingers or hands and twisting back and forth. Ponga la clavija entre sus dedos y muévelos girando hacia adelante y hacia atrás. TVs and movies consist of images flashed 60 to 72 times per second. Your eye and brain blend the images together and create the appearance of continuous motion. When we experience a distortion of our vision and see something that is different from reality, that is called an optical illusion. Or we could say it in Spanish, ilusión óptica.
Let's look at a picture of a car and a picture of a moving landscape to show how the eye can make them seem to overlap. Let's run them on the screen, one after the other. We look at them for 2 seconds each. Then for 1 second each. Now, faster and faster until we see the 2 pictures as if they were both one picture. Another optical illusion.
When you look at a picture, then quickly flip to another one, your eye and brain remember the first picture for a split second and then blend it with the second one. This is called persistence of vision, and that is what makes the pictures in movies seem to move. In Spanish, you would say persistencia de la visión.
Motion pictures are based on an optical illusion. Just another case where seeing is believing. To understand how we see, let's turn the tables on the human eye and look at it instead of through it. The light, reflected by any object we look at, passes through the lens of the eye and is focused upside down on the sensitive surface called the retina. This retina passes the impression on to the optic nerve, which sends it to the brain, and we see it right side up. The reflection will stay on the retina as long as the object is in view. When we look away or take the object away, the images disappear. But notice that the image in the brain does not disappear immediately. It fades a fraction of a second after the object is removed. This slow fading is called persistence of vision.
Let's go ahead and talk about safety. During the building process, be careful pushing the dowel into the cardboard. The pointed end could cause injury or rip the cardboard if done too quickly or forcefully. When spinning the Thaumatrope, be sure to hold it about 12 inches away from the face and the eyes of people and animals. Do not let go of the Thaumatrope while spinning it, as it may result in injury or damage to property. Okay, now I got a couple questions for you to think about as you experiment with your Thaumatrope. Question 1. What would happen if you had 3 or 4 sides to the Thaumatrope? ¿Qué pasaría si tu Thaumatrope tuviera 3 o 4 lados? Question 2. Are you better able to see your optical illusion if you spin your Thaumatrope more quickly or more slowly? ¿De qué manera puedes observar la ilusión óptica, moviendo tu Thaumatrope más rápido o más despacio? Comment below with your thoughts and ideas, and remember to like this video and subscribe to our CSW network for new virtual STEM lab projects. You can also visit our website at cswnetwork.org for free access to our project library. This is Mr. G. Until next time, we'll see you in the next project.